In this video, we're going to be multiplying two fractions together. So something like 3/5 times 4/7. Okay, and this is where our times table is super important for the non-calculator paper, but we're going to simply times the two top numbers together, the two numerators, 3 times 4, which is 12, and on the denominator, we're going to do 5 times 7, which is 35. And it's as simple as that. Top times top, bottom times bottom. Okay? Now, with fractions, we're always expected to simplify them, which means cancel them down. And in this case, are there any numbers that go into 12 and 35? Well, the only one is 1, and so this is fully simplified already. Okay, what happens if we have one that has something on the top and the bottom, like this? 3 times 5 is 15. 5 times 7 is 35. And we can see that because they end in 5, then 5 will definitely go into both. So 5's into 15, we cancel and put a 3 there. 5's into 35 go 7. So our final answer here would be 3/7. Okay, now if you look closely at these, you might see that the kind of answer is this, and the 5's kind of disappeared. 3/7 became our final answer. So what's happening there? Well, as we progress in maths, we want to try to avoid cancelling at the end, especially in the non-calculator paper where these numbers might be large and you might not be so familiar with their times tables and their factors and everything like that. So for example, 10/17 times 34/100 or something like this. If we do top times top, 340, and 17 times 100, 1,700. Like, that's a lot of work to cancel this down. Okay, we can potentially go 10, divide top and bottom by 10, but we've still got to do 34 and 170, and we might not know all of those factors. So when we're doing our multiplying fractions, we'd like to cancel first. 5/9 times 18 out of 50. Okay, we can look up and down and see if there's any common factors. So 5 and 9, nothing divides into 5 and 9 except for 1. 18 and 50, yes, they're both even. So we might consider dividing both of them by 2 first, like this, and starting from that calculation, because the numbers are a lot smaller. 18 times 5, 90 over 450. Like, we don't want to be cancelling that. So we're trying to cancel up and down wherever we can, and we can look at the diagonals. So I'm just going to rewrite this so it looks a little bit clearer. We've now got 9 and 25 here. We can look at the diagonals. So the cross here kind of shows us where we can look for factors. So 9 and 9, we can cancel this by 9. 9's go into both of those one time. And if we look at the other diagonal, we have 5 and 25. So 5's go into 5 once, and 5's go into 25 5 times. And now, when we finish this top times top, 1 times 1, and bottom times bottom, 1 times 5, all of that cancelling has been done for us. Okay? Now, this obviously looks scary, okay? Like all this cancelling nonsense, but it's easier than potentially 90 over 450. You know, 2 goes into both of these. What's 2's into 400? 225. And this is a lot of work. And the more work you give yourselves, the more chance you have of making mistakes. So we look to the diagonals to try to cancel those first. Okay, 10 over 14 times 28 over 100. Okay, we can look up and down and we can look at the diagonals. So 10 and 100, 1 and 10, because 10 goes into both of those. And if we look at this diagonal, 14 goes into both of those, but we might not spot that, so let's just do 2. 2's into 14 goes 7, 2's into 28 go 14, and we can keep going, 7 and 14, so 7 goes into 7 once, and into 14 twice. So we've got 1 times 2, and 1 times 10, and yeah, we can keep going because we had the 2 and the 10 there. We might not have spotted that. 2's go into this once, and here 5 times. Okay, how much easier did that compared to 10 times 28 and 14 times 100, trying to find the factors of both of those. So consider this diagonal and up and down cancelling before you do your multiplying, and as you progress, the harder questions require us to do this. So it's a really good skill to learn as soon as possible.